All right, you ready? Yeah? Thanks, man. So, the way I could introduce this guy is actually he's from North Germany, and this morning, you know, as I I get afraid of the cold, he actually walked outside without a hoodie on. So that surprised me. I'm like, something is off, but he's smart because, you're an open source hacker, right? That is correct. So I will give you the mic. They will give you a big round of applause. Go.
All right. Can you hear me? Yeah, cool. So my name is Jendrik. Thank you very much for the opportunity to talk to you today. It's super my pleasure. Really cool. So I'm from TokenAnalyst. We're a bunch of hackers, 6 people from London. And what we're doing, we're interfacing blockchain data, on-chain data, completely agnostic. So we're not Ethereum only, but we also support Bitcoin, of course. Yeah, so if you want to see what I'm up to, you can follow me on Twitter, Made with T, mostly posting about mechanical keyboards. If you're into that as well, it's cool, be cool. Otherwise, yeah. So here's a gist of what we do. So we are processing raw blockchain data. So here it's an example for Ethereum. So what we do is we classify address labels. We can say, okay, this is a human, this is a bot, this is an exchange, this is a smart contract. What kind of crypto asset, and what amount of is transferred, and then of course classification. Why are we doing this? Who are our customers? So we're financially backed by hedge funds, so completely different space. People who are gambling with money, and they want to know what's going on the blockchain, of course. So we're not a typical blockchain company per se. So it's more of using the blockchain to extract the data. So bear with me. So these are the use cases. So we are tracking exchange in and outflows, big movers, token treasury, liquidation. So if people raise a lot of money on the ICO, smart contracts that we can see, okay, they're liquidating it for whatever reason. Anomalies, project company KPIs, for instance, what's pretty interesting right now in the finance space is DeFi. So it's basically KPIs. There are a lot of projects going into all different kinds of spaces, lending, platforms, stuff like that. They have their KPIs as well. So they're companies, they have to make profit. So what they're mostly not looking into is what data is on the blockchain. And this is why we're going there and extracting all these kinds of information, data for them as well. So, and then transparency reports. So basically, like general reports, what's going on in this space, how much money is transferred, but also what are the weird things that happen on the blockchain as well, and then doing some research. So yeah, quite fast. So this is what we're up to in the media. So we're working with newsletters, for instance, Dyer. We have some research with Dyer, with BitMEX. They're pushing out a lot of research posts regarding also investing, and we did a small research on the nonces, the nonce space, which is not distributed in Bitcoin equally, which was pretty interesting. And then we're also working a lot with node client software, so we run a bunch of parity nodes and geth nodes, of course, ourselves, and we came across all the different quirks that you have to overcome to integrate these nodes into an ensemble of a reliable cluster of nodes. Okay, cool. So now let me talk about trusted data. So I'm a data engineer originally, so 6 years working in all kinds of like big data, fast data, maybe now trusted data startups or bigger companies, and so in all different kinds of fields, like from IoT to smart home to video, peer-to-peer video distribution. And yeah, so my trade is basically data. And since a couple of years, I'm also interested into Ethereum. And I started writing scripts to extract data. I think it was 2 or 3 years ago. And right now you have a bunch of open source software to extract data from the blockchain, which is super amazing. It's probably like 10 to 15 different open source projects just to get data out. And they're all doing their job more or less good. So yeah, but you should give it a try for sure. Yeah, so I was looking into smart contract data because or smart contracts I wanted to know what kind of data can I get out of it, or how does it work. The idea of smart contracts is very transformative. I mean, it started with Bitcoin, then you had Bitcoin script, then you were able to write Bitcoin script to do like any kinds of, not any kinds of computations there yet, but it was a stack-based language which you can use to do more complex locking scripts. That was super nice. And then Vitalik came up with the idea of let's use a von Neumann machine, basically a virtual machine, the EVM, to run any kinds of code on the blockchain. And that was very transformative. And then we came up with smart contracts. Then we came up with standards. Now we have ERC20. Now everybody's thinking about ERC20, or was thinking about ERC20. Now we have the 7-to-1 and crypto collectibles, and every new standard and every new idea is basically shaping the next big thing, which is super interesting. And also with the hype cycles, it was in Mt. Gox. I remember I was buying Bitcoin on Mt. Gox, and I was also one of the guys who lost money on Mt. Gox, basically, when it was hacked. And that was the first wave. And then the next big hype was basically when Coinbase was there, or Kraken, and all the other new exchanges, which transformed our thinking, like how can we buy cryptocurrency and how can we use it, which is super important because user experience, I think, is very underestimated in the space. And maybe the next big cycle is cards, for instance, cards which you can pay with on the ADM, which is way more important than anything else right now in the space, I think. So saying that, trusted data, coming back to that, so big data, fast data, and trusted data, I see that as a next paradigm shift, because there's so much data on the blockchains, and basically you can look at it on the block explorer, but it's just a small view on the blockchain, and it's not like you can run queries or something. You cannot say, okay, who owns the most blockchain, who owns the most Bitcoin, who owns the most Ether, or who has transacted not in the last year or something like that. That is the real power, and this is something that people can do when they have access to it. So, yeah, so I talked about transformative ideas, so we have to think about, okay, what's the next big thing? It's crypto collectibles, then we have like DAI, and what could be next? And what we underestimate, in my opinion, is UX and the whole trusted data, or the data aspect of it, because we're generating a lot of data, but we don't look at it, like from a big picture point of view. So what I also put on here is the all-seeing eye, and I just want to put this all into perspective, because we are talking about this, we're talking about privacy, we're talking about generating data, and we're talking about the bad guys, I don't know, Chainalysis, Elliptic, us maybe, and we have to see from a bigger picture, because there's the NSA out there, they can basically read everything, and this is something, maybe it's an eye-opener for people. So on-off-chain data. So we're doing on-chain, but off-chain is basically all the other data that's out there, traditional data, which is basically your Facebook profile, Twitter profile, and whatnot. And basically, what is about to come is basically joining these pools of data. So that means that any address that you hold can be basically joined to your user profile, and then people know exactly what you own, and can basically target you via advertising or something like that. And this is a very profound thing, because everybody has basically access to these blockchains, right? I mean, everybody can extract the data out. So now I'm talking about power and information asymmetry and transparency for governance. So there is this paradox. On the one hand, we want blockchain to become transparent. It's kind of transparent. You can go on a block explorer, you can go on Etherscan, and you can see the smart contract. But there's so much things that you have to overcome to really be independent to figure out what the heck is going on. So, and these are kind of the layers. So basically, the ground layer would be peer-to-peer network. You have your client, which is super hard to install. Then you have to sync it up. That's also hard. Then you have to figure out a bit, okay, what are the consensus rules? Then, okay, transactions. From here, it's standardized, right? This is all standardized. It has to be standardized. But everything that comes here is like completely customizable, because we're dealing with a Turing complete language, or EVM here. So we can think about all kinds of computer programs that have all different shapes and colors and methods and events and whatnot. So every smart contract is completely custom and it's very hard to access. So what we can do is we can create standards here, which is, for instance, the ERC20 token or 721, and then we can integrate it to other entities, for instance, exchanges. So you can trade an ERC20 on an exchange or a 721. Or you have OX, for instance, as a layer. But in order to understand what the company is actually doing, or the developers, because the developers are in charge here, basically, because they can define how the smart contract looks like, and what do I show, basically, the investors or the people, or what don't I show to the investors and the people. That was really interesting for me, because when I was learning Solidity to read smart contract code, it was an eye-opener for me, because I could go on Etherscan, I could read smart contract code, and then I could understand, okay, this token is actually mintable. I did not know that before because nobody told me, but now I can see it in the code. So we have to understand that the transparency is super important, otherwise governance will not work. You always have to trust people that they do the right thing, no matter how decentralized a smart contract is. Yeah. And then what's kind of interesting, so yeah, we need standards. An ERC20 token is not an ERC20 token, so it's just an interface that it behaves like an ERC20 token, but in the back end it can sell my grandmother, basically. Can call any kinds of code, right? It could be a smart contract call to another smart contract, which is doing something else when I transfer an ERC20 token, because the implementation can be completely different from what it says it is. Okay. So here are the weird quirks that we found, just as like a brain teaser, I would say, maybe. So working with parity and geth, we figured out some stuff that we had to overcome in order to get the data out. And when I mean get the data out, I haven't talked about it, but on this slide, which is pretty interesting. So what we did in December, we were instantiating 60 parity clients just to extract the whole Ethereum blockchain. And when I mean the data, I mean everything. I mean call traces, I mean state diffs, everything. So, we needed to spend 3.5K to do this in 5 days, just to put it in perspective. And the data in binary format is like 1.5 terabytes big. Okay, so now about the quirks. So, for instance, there are different call traces and different parity versions. We found it out for some transactions. It's a minor thing, but it would be better if, first off, parity and geth are doing a great job. It's absolutely amazing. We're big fans of parity because it's faster, it's more stable, and it is always in sync. It's really cool. And I know that the trace functionality is also like something that's new to parity. Geth, for instance, doesn't have it, but we really rely on it, and it would be cool if it would be more consistent. But of course, we know it's like experimental, the whole space is experimental. So then we have reorganization stuff. So for instance, if you just subscribe to the blockchain and there is a reorganization happening, you don't get it from the subscription that there was a reorganization happening. So you have to basically find your way around it, how to do it. So in order to get the blocks from the right canonical chain, which is also a bit weird to deal with. And then there's some other things. So for instance, the RSV fields and transactions are not consistent, so they're different in parity, different in Fura, and different in Geth. This is just like type inconsistency, like how the values are presented. And then different error responses, so that makes it even harder to deal with the clients. And then it's not type safe. So I'm a big fan of type safetiness, and it just helps to keep the data in integrity. So that would be very, very cool. I know the whole space is experimental, and because of moving fast, it's super nice to have a JSON interface, JSON RPC. But the fact that this should be used as a schema or a standard, it's probably better to put types there in order to not to prevent any misunderstandings. So this is like a Bitcoin graph. So we're dealing with streams. We have low latency streams. We get our blocks. We get our transactions. It's all going through the pipeline. We're doing confirmation checking from different. We're using all the blocks and transactions from different nodes. We're doing the checking. We put them into other data streams. Do some aggregates on it. We're also putting the data into graphs, and this is just the Bitcoin graph. So you have UTXOs, you have TX transactions, you have Coinbases, you have miners, and then you have addresses which own the keys to the unlocking the UTXOs. And this is just a very simple graph. It is way more complex if you do it for any kinds of thing in Bitcoin. So here we're just scoping it down to the public key hash, not to the pay to script hash, which is more like a script to unlock or lock the UTXO. But it can get very complicated. But having this, we are able to trace the money through the graph. And so what we're also doing right now, or what would be great, is we're having the call traces. There are a lot of ABIs out there. There's this reversal lookup service called 4bytes, which allows you to put like the signature of the method into the database, and then you get basically the method name out. And what we can do then is we can build a graph of smart contracts which are calling each other. So this is what you want to have basically, right? To understand which, oh, time's up, okay. Just very quick wrap up here. So we have the infrastructure out. We have a low latency data stream. You can subscribe to it. We have an SDK. It's called npm install TokenAnalyst/SDK. And with 3 lines of code, you can basically get transactions, you get labels, you get price. And we can build cool prototypes with it. And docs. And we're hiring, so we're a 6-people team. It's an absolutely amazing team. I love to work at TokenAnalyst. Absolutely great people. Please write me an email if you're interested into that. We're also looking for, right now, a front-end engineer, data engineer. Cool. Thank you very much.
Thank you. Okay.